Okay, so for my statistical analysis, I chose to do the example of a one-way ANOVA. So the example I'm going to use is just from the Andy Fields textbook. So the example is of a company manager who wants to improve the efficiency of his employees using a particular spreadsheet within the company, but isn't sure on what level course to send his employees on to improve their efficiency. So he decides to send 3 groups on the same course but on different levels. So 10 go on the beginner course, 10 go on the intermediate course, and 10 go on the advanced course, and then see which level was the best in improving the efficiency of the employees that using the spreadsheet. When they return from the course, he will time them at doing solving a problem on the spreadsheet to find out which course was best. So the data here, so we've got the 2 columns, course and time. Number 1 indicates the beginner level course, number 2 indicates the intermediate level course, and number 3 indicates an advanced level course, and then the respective times for each individual that was recorded once they'd returned from the course and were given the problem to solve. So for the one-way ANOVA, this is used to test 2 or more means, which is what we've got. There are a few assumptions that you have to meet before doing the statistical analysis. So you have to ensure there's no significant outliers within the data set. There are 2 or more categorical groups. The data should have homogeneity with regards to variances, and the major one is to ensure that the dependent variable is normally distributed. So to test for that before we actually do the one-way ANOVA, we will test for normality within the data. So to do this, we'll go on to descriptive statistics in the Analyze tab, and then within this descriptive statistics tab, we'll go on to Explore. So in the dependent list, we want to put the time, and in the factor list, we want to put the course, and then we just want to make sure that these all are ticked correctly. So we want to, in the statistics section, we want to make sure that descriptors is ticked, and then in the plots section, we want to make sure that normality plots with tests is also ticked, and then we can run the normality test. And then if we scroll down to the last table, the one that we're interested in is the Shapiro-Wilk test. The reason for this being that this test of normality is used on samples of less than 50 usually, which is what we've got. We've got 10 in each group, so that totals 30. And then what we're looking at is the significant difference at the end to make sure that this is greater than 0.05, which they all are, which indicates that the data is normally distributed. So we can then crack on with the one-way ANOVA. So if we go back to the original data set, we can then go back into Analyze in the Analyze tab, but this time go to Compare Means and go to the last one, the one-way ANOVA. And again, we want to make sure that the dependent list in there is the time, which is of course recorded in minutes, and in the factor list we want to make sure the course is in there, and then we want to make sure in the Post Hoc tab that the 2 key is ticked. That's the only one we're concerned with, and everything else looks absolutely fine. So again, we can run that, and here we are. So this is the output. So on here we've got so for the means of each group. So the mean time for the beginner group at solving the post-test task was 26.8 minutes. For the intermediate group, it was 19 minutes, and for the advanced group, it was just over 15 minutes. We then go on to the ANOVA table. This will then break down the significance. So as we can see, the advanced group become a lot more efficient at solving the problem, and this was statistically significant. That concludes my example of the one-way ANOVA.